Remainder theorem. So I'll explain the complete theorem and including problems. So how to solve the problems based on this remainder theorem. So before that, let us see the statement. Let us discuss the statement of remainder theorem. Then we'll see the problems based on this. You must understand what is the theorem and how to use. So let P of x, okay, P of x be any polynomial. Any polynomial you can take, but the condition is of degree greater than or equals to 1. Is the first one. So degree should be greater than or equals to 1, right? If the degree is 0, then it's only constant. So degree must be greater than or equals to 1. And take a number, let it be a. Is a any real number? A is any real number. These two statements. P of x is a polynomial greater than 0, that greater than or equal to 1, the degree, and a is any real number if P of x is divided by the polynomial. P of x, we are taking polynomial, no? That P of x is divided by x minus a. Then the remainder is P of a. Then the remainder is P of a. So without doing division, we can find out the remainder. This is the concept of this. So let us understand this clearly. P of x, let it be any polynomial. The degree is greater than or equals to 1. So let us take with example P of x. I am taking one polynomial, okay, 4x cube plus 7x square. You can take anything, minus 5x plus 3. Let be this is the polynomial, degree is greater than or equals to 1. Okay, degree is a 3, highest power. So is a 3, that is a degree, right? And a is any real number. So for example, it's divided by x minus a. Okay, is any number. In case P of x is divided by x minus a, let this is divided by x minus 1. That means the place of a is 1. A is equals to 1. That is any real number. Then remainder is P of a. So if I do division, this P of x is a polynomial. If I do divide by x minus 1, remainder I should get P of a. Okay, x minus 1. So from this, if you want directly, you can take that x minus a, no, that is equals to x minus 1. So from this, a is equals to 1. Right, that should be x minus a according to the statement. A is equals to 1. Now the remainder is that you can find out. So P of a, that is equals to P of 1. In the place of a is 1, right? So P of 1, 4 into 1 cube plus 7 into 1 square minus 5 into 1 plus 3. Let us do this division, calculation. 1 cube is 1 plus 7 minus 5 plus 3. This is 7 plus 3 is 10, 14. 14 minus 5. So it's a 9. So we got the remainder is 9. So therefore the remainder is equals to 9. So if anything is divided by some other polynomial like x minus 1, then except x value should find out. In case if it is 0, x minus 1 is equal to 0, then x is equals to 1, right? So a is equal to 1. Let us check this is exactly remainder is 9 or not with normal division. Only one division will do. So let us take this, only for testing I am doing. 4x cube plus 7x square minus 5x plus 3. I should divide this by x minus 1. Then I should get the remainder is 9. Right? I already 9 I got. Let us check this. X and 4x cube. Previous topic we have checked already. X into dash is 4x cube. That is 4x square. Okay, take this one and this you verify. X into how much you should multiply to get this. That is 4x square. Take this 4x square and multiply this entire. So 4x cube minus 4x square, because 4x square into minus 1. We subtract this and change the sign, cancel. 7 plus 4, okay, it's 11x square. Next term take down, minus 5x. Again with x and this 11x square. So if you see this, x into dash is 11x square, that is plus 11x. 11x into x is 11x square and 11x into minus 1. So minus 11x. Take the minus and this change the sign, cancel this. Minus 5 plus 11, it's a 6x. Now we'll take the next term, that is plus 3. Now it's x and 6x, right? So plus 6. 6 into x is the 6x. 6 into minus 1 is minus 6. You can subtract, this is change the sign. So here is a cancel this. 3 plus 6 is 9. Yeah, we got the remainder is 9, right? So no need of doing division this all. Instead of doing division, we can apply this rule directly. Okay, based on the statement. So if x divided by x minus 1 means x minus a. So a value is equals to 1. You can substitute, we get the remainder. Let us do one more problem. Okay, for example, find the remainder. Using this remainder theorem only, I'll do one more example. You can like this, you can do anything. So find the remainder when 4x cube minus 12x square plus 15x minus 3, and this is divided by, and that is 2x minus 1. We should find out the remainder when it's divided by 2x minus 1. So if you want here 2x minus 1, this is x minus a. If you know directly, we can do here one simple step. 2x minus 1, just to make it as, let this equal to 0, because x minus a, if I take equal to 0, then x is equals to a, right? In the place of x only, substituting a value. Same concept you can apply here. Whatever is we should divide, that we will take it as 0. From this you will find out x value directly. 2x is equals to 1 and x is equals to 1 by 2. X minus a, if 0, then x is equal to a, right? Similarly, x is equal to 1 by 2. Now we need to find out, this is a now. So x is equal to 1 by 2, that is a. This is the p of x. The polynomial is p of x 4x cube minus 12x square plus 15x minus 3. 15x minus 3 can apply. So then x is equals to 1 by 2 here. Just you can substitute, that is the only remainder. According to the theorem also, you can do this shortcut directly. Then remainder. So remainder is p of x, right? X is 1 by 2. Just substitute in the place of x 1 by 2. So this is the remainder. So 4 into 1 by 2 cube minus 12 into 1 by 2 square plus 15 into 1 by 2 minus 3. Let us simplify, whatever you get, that is only remainder. Just it is 1 by 2 cube. So 1 by 8 minus 12 into 1 by 2 whole square is 1 by 4. This is a 15 by 2 minus 3. Cancel the terms possible here. 4 ones are 2s are. Again 4 ones, 4 3s are. So I got 1 by 2 minus 3 plus 15 by 2 and minus 3. You can simplify this. Okay, 1 by 2 is 0.5. Minus 3 is minus 6. Plus 15 by 2 is 7.5. In case if you write decimals. 7.5 plus 0.5 is 8. Minus 6 is 2. So remainder is the 2 now. Just only simplification I did. The concept is whatever you should divide, you can make equal to 0 and find x value, directly can substitute here. There is only remainder. Otherwise, you can make equal to x minus a. Just assume that x minus 1. In this also you can do. These are the two ways you can find out. Right? This is the remainder theorem. Now let us see next what is the factor theorem and how to do the problems based on the factor theorem.